In an experiment, 15 babies were asked to watch a climber attempt to ascend a hill. On two occasions, the baby witnesses the climber fail to make the climb. Then, baby witnesses either a helper toy push the climber up the hill or a hinderer toy preventing the climber from making the ascent. The toys were shown to each baby in a random fashion. A second part of the experiment showed that the climber approaches the helper toy, which is not a surprising action. Okay. Then the climber approached the hinderer toy, which is a surprising action. The amount of time baby watched the event was recorded. The mean difference is time spent watching the climber approach the hinderer toys versus watching the climber approach the helper toy was 1.03. So for the sample, mean difference was given 1.03 seconds and the standard deviation was given 1.89. Okay. State the null and alternate hypothesis if determine if the babies tend to look at hinderer toy longer than the helper toy. So the question is if the hinderer toy's mean time was more than the helper toy. So basically what we are trying to say that if mu d is mu hinderer minus mu helper, so mu hinderer minus mu helper has to be positive. That is what we are testing. That is our test about. So that will give you your H1. What is this value? This is mu D. So your H1 would be mu difference is positive. H naught is that always equal to 0. So that's what you need to write in your alternate hypothesis. So look for those alternate hypothesis mu naught difference is um, 0 and mu d is more than 0. I think that's the correct option. Okay. Assuming that the differences are normally distributed, they are giving you the verification statement and there are no outliers, right? And this is a random sample. So all the requirements are verified and level of significance is equal to be 0.10. We need to calculate the test statistic. How do you do that? Because this is matched pairs, the same baby is doing watching in both the times, right? So you need to run t-test for the means. And in this question, not data is given, stats is given. So you need to first highlight the stats. Mu naught is 0. Mu naught is this right hand side value that is 0. So 0. X bar is given to be in the question 1.03 seconds. So you need to write 1.03 seconds. So 1. Standard deviation is given 1.89. Number of babies is 15. So sample size is 15. And we are testing more than 0. So you need to highlight more than value and then press calculate. This is what we are getting. So we are getting T to be 2.11. So that's what you enter. Okay. And P value is 0.02627 if you're going to round it to third digit. Okay, what's happening here? P value is, let's note it down. P value is 0.027 and alpha is given to be 0.10. So P value is less than alpha. That means what? That means reject H naught. So let's do that. Reject H naught. If we are rejecting H naught, then we are accepting alternate hypothesis. That means there is sufficient evidence at this level to conclude that difference is more than 0. Okay. So what do you think this experiment implies about baby's ability to assess surprising behavior? There is sufficient evidence. The babies have the ability to assess the surprising behavior or there is sufficient evidence that baby do not have the ability to assess the surprising behavior. So what happened is that we said that there is sufficient evidence to conclude the difference is more than zero. So the difference is more. So babies are capable of assessing surprising behavior. That is it for this question. Let me know if you need help with this or anything.